Welcome to Tech in Translation, the podcast where we break down the complexities of today's most innovative technologies into something we can all understand.
Brought to you by Ironbow Technologies, a leading IT solutions provider. We're committed to helping our customers across the government, education, commercial, and healthcare sectors turn their tech challenges into real, actionable outcomes.
At Ironbow, we believe that technology should be a tool for empowerment, not a source of confusion.
That's why each episode of Tech in Translation is designed to demystify the latest trends, tools, and technologies, making them accessible for everyone, whether you're a seasoned professional or just tech curious.
Join us as we translate complex tech into everyday language, one episode at a time. Welcome back to Tech in Translation. I'm your host for today, Fran Elatros Ukejofo. Today, I have joining me Jim Engel, Collaboration Architect at Ironbow, and Jeff Ward, Practice Director for Infrastructure Automation. And congratulations to you both again on winning the Cisco Partner Innovation Challenge for 2025.
Thank you. Happy to be here.
All right, so let's just kind of start by setting the scene, talking about what this challenge is, why it matters. Jim, we'll start with you. What inspired your team to pursue this idea in the first place?
Well, the initial idea came from the real-world issues that nearly all of our customers are facing ever since the federal Baum Act went into effect, and specifically Phase 2 of the Act, which mandated the ability to provide location information for remote and roaming users. And meeting this new requirement has been a challenge. Our customers each already had their solutions and processes in place for supporting 911 calls, but overnight, these new legal mandates made some of those solutions, unacceptable. For many customers, their wireless networks and IP addressing schemes were just not designed to meet these new mandates. So to get compliant with the new rules, different customers have taken different paths. And for most of them, they have found that it now takes multiple products from multiple vendors to be compliant. Now, there are many national 911 providers who our customers use, but for this innovation challenge, we were focusing on the solution from RedSky, since this is the partner that Cisco is working with for their UCM cloud and dedicated instance solutions. So now companies have multiple systems to configure and ensure are correct in order for a 911 call to work properly. What's more, most of this work is all manual. And it also requires engineers from multiple teams to get things configured. We need information from network engineers as well as telecom engineers to keep information synced for all of this to work properly. It's just a situation that is ripe for miscommunication and misconfiguration and things getting out of sync. For something as important as 911 calls, that's just not acceptable. Initially, what we wanted to see was whether we could find a better way to alleviate this ongoing administrative struggle and make this process more simple and reliable for our customers.
So a lot you shared there on the back end, but I think the really key takeaway here is this is to really ensure that 911 calls, can be dispatched quicker. They can find the people who are calling, the survivors or victims faster. This was a really important cause and a really important purpose, and there's so much that went into the back end there. So Jeff, can you take us back to the moment when the idea first started coming together and what problem you were trying to solve for?
If I go back to the moment it really started coming together, it wasn't like a big light bulb went off. It was more like a series of uncomfortable conversations that all pointed to the same problem. We were working on the automation, and we kept hearing the same question. When someone dials 911, do we actually know where they are? Not just the building, but the floor, the wing, the room. And when we started mapping out the workflow on a whiteboard, it was eye-opening. We knew the general location from what access point the device was connected to, but considering Wi-Fi bleed, the user's actual location still spanned a large area. That's when someone asked if we could use the same technology that Tile or Apple AirTags use to find devices. At that point, the original problem became twofold. One, eliminate the manual, error-prone, swivel chair work between Catalyst Center, Call Manager, Emergency Responder, and RedSky to meet the 911 regulations. Two, turn all that location intelligence into something actionable in the field. So when someone calls 911, we're not just compliant on paper, we're helping first responders get to the right person in the right place as fast as possible.
Just incredible. I mean, how you framed the situation there. Like, do we actually know where they are when 911 responders are calling, and just what went into the back end about this? So I know, Jeff, you mentioned a bit too about the technical side, and Jeff, you've been diving into the challenge as well. Specifically for hospitals and campuses, what problem were they facing that sparked this solution?
So the challenge we saw was very basic. Hospitals and campuses had no reliable way to keep their 911 related data in sync across all the different network and telecom systems. Every time a new wing opened, a floor got a tech refresh, or an access point moved, somebody had to update Cisco Catalyst Center, then separately update call manager, emergency responder, and go to Red Sky to do an update. Different teams owned each system, and all that happened through tickets and spreadsheets to pass the information between the different groups. It was slow, it was repetitive, and incredibly easy for one system to lag behind the others. And that manual model just doesn't scale in a large environment. Location data could drift over time, engineers were constantly rekeying the same information, and leaders had no confidence that what was in their different databases actually matched reality. And that's really what sparked the solution. We wanted to treat 911 location and routing data like an automated pipeline. So instead of a bunch of disconnected updates, so you declare it once and it stays consistent everywhere it needs to be. For example, how can we install or move, say, a single wireless access point to a new physical location? When you do that, you have the network engineer who is doing the installation update one interface and have that information pass automatically from the network systems into the telecom systems to the national 911 provider and update everything automatically without having to open additional tickets or re-enter the data.
And all of that on the back end is happening because every second matters, right, for that 911 call and to find and triangulate them. So just incredible to think of what processes and pipeline and data that you had to navigate there. So in terms of the compliance component, why is emergency response compliance, like Kerry's Law and the Baum Act, such a difficult requirement for organizations to meet?
On paper, laws like the Kerry's Law and the Baum Act sound straightforward. Let people dial 911 directly and make sure the call includes a precise, dispatchable location. With the first phase of the Baum Act, this worked just fine. But phase 2 added mobile devices. We've designed our networks so you should be able to move around and work from anywhere, and everything works the same. We don't care that you're at home, at the coffee shop, or moving around the building. We want our networks to not care where you are and allow you to be mobile. Well, all of a sudden, knowing exactly where you are is the most important thing we have to do. And that's the new challenge the Baum Act threw at us. Compliance isn't just we did it once, it's can we keep this accurate every day across all the tools and prove it. Without automation and a single source of truth, organizations rely on manual updates and tribal knowledge to keep life safety workflows running. And that's why meeting these requirements consistently is so hard and why it's precisely the problem we set out to solve.
Amazing. And we talked about what challenges these solve for the 911 responders, for the hospitals, for the campuses. But let's really take it home. How do these issues translate into real-world consequences for people on the ground during an emergency?
Well, when these systems aren't in sync, the impact doesn't show up as a bad field in a database or anything like that. It shows up as lost minutes for real people who need immediate help. Our goal with the Baum Act is not just to give a generic address for a person who's calling for help. We're trying to get information down to the floor or possibly the room where they are calling from, because in an emergency, every second counts. If all the first responders get is just a campus address, then they have to go hunting and searching. This requires checking multiple entrances, stopping at the security desk, calling back, or walking down the wrong hallway before they finally find the person in distress. On the ground, that feels like confusion and delay. Nurses and staff are pulled away from patients to help track down where the call actually came from. Security is juggling radio traffic, and meanwhile, the person who needs help is still waiting, while everyone else is still sorting out a location problem that should have been solved upstream. And as much as we hate to talk about it, the real worst case is if the information has gotten so out of sync that the information is just wrong. We've all heard the worst case scenarios in the news of first responders coming to the wrong address to help someone. Well, those situations are real. And those tragic situations arise when information is not properly synchronized and updated in a timely manner.
Yeah, I think that would give all of us goosebumps. So, I mean, really, thank you for painting the real world impact there. And you talked a lot about what goes on in the back end, what needs to be connected, what needs to be automated. So, for those of us out here who aren't engineers, how would you describe the solution in plain language?
I describe it in two parts. First, we keep all the critical 911 information in sync automatically. Today, hospitals and campuses have different systems for the network and the phone system. Normally, people type the same information into each system by hand. We replace that with one workflow. You update things in one place, and our platform makes sure all the other systems match. Second, when someone places an emergency call, we use the network to help find them quickly and accurately. We combine what the phone system knows, what the network knows, and what the location tools know, and turn that into a clear visual view for responders where the caller is and how to get to them. So in plain language, we take a bunch of separate systems, make them all act like a single brain, and use that to guide help to the right person faster.
Thank you. I like that breakdown, Jeff. I think thinking of that brain that's guiding all these decision making and automation in the back end. So that's very helpful. And I know we touched on earlier, this is basically a platform that connects a whole bunch of Cisco tools, Catalyst, Center, CER, Red Sky, Spaces, and Splunk. What's unique about why these are all connected? Why should anyone care?
Well, what's unique is we're not asking anyone to rip out and replace anything. We're leveraging the Cisco suite of tools that they already own. So the networking team is using Cisco Catalyst Center for managing the network. This becomes our source of truth for the locations for the networking devices. Network engineers update locations, devices, and floors there once in Cisco Catalyst Center, and then they're done. Our platform then automatically pushes those changes downstream into emergency responder, Red Sky's cloud applications, and the call manager environment, which telecom engineers are usually managing. Meanwhile, Splunk watches for 911 events and triggers our app when a call is made. For enhanced location services, we leverage Cisco Spaces to provide precise location data from Wi-Fi, BLE beacons, and devices. So instead of separate technology islands, we have them behave like one coordinated safety system. Each Cisco tool still does what it's best at, and our solution handles the translation, synchronization, and automation between them.
Amazing. So this platform is basically integrating all of that together. And how does the integration of all these moving parts help organizations respond faster when, as we've emphasized several times, seconds truly matter?
Because everything is integrated, the response sequence becomes automatic instead of manual. When a 911 call happens, Splunk detects it and signals our application. We identify who's calling, then use the sync data from Catalyst Center, Emergency Responder, and Red Sky to understand where the caller should be, and Cisco Spaces to pinpoint where they actually are. All of the plumbing happens behind the scenes. So on the ground, it feels like this. The moment someone dials 911, the system knows who they are, where they are, and how to guide help straight to them, shaving off the minutes that usually get lost in confusion and lookups.
That really helps kind of paint it in the eyes of the emergency responder. So thank you, Jeff. And as we've been reiterating over and over, this solution clearly goes beyond just the tech and compliance. It's about saving lives. So how and why was it important to you to approach this not just as another tech challenge, but as a human one?
Well, to be honest, we initially did approach this as a technical question, but that did change as we got discussing things amongst the team. Let me put it this way. When I'm in a design meeting with a customer, I always try to think past what am I installing or what features am I configuring, but instead look at what problems are we solving or what outcomes does this customer need. This was definitely one of those scenarios. Meetings about Baum Act typically focus on legal requirements and compliance. But for this project, instead of looking at questions of legal compliance, we started asking questions around what happens when a call routes to 911? What happens when a first responder arrives at a site? What can go wrong in this process? How could we locate someone quicker? How about with more accuracy? This attention to what happens in an actual emergency kept us focused on building something that could have a real impact. Now, don't get me wrong. Legal compliance with the Baum Act is important. But frankly, if you think about it, it's only important for the company, not for the person in distress, not for those people who are coming to help. Our focus was on what people needed in an actual emergency. Keeping the information accurate and in sync for 911 calls was the problem to be solved, and getting help quicker was the outcome that we needed.
I love that, Jim, and I love how you touched on, too, starting with the human need and for the outcomes, and then working through, all right, this is where we align in the terms of the tech challenges and solutions. So thank you. Jeff, you have built in some fascinating visual and auditory elements like the real-time map and sonar ping to help first responders locate people. Can you explain how that works?
Sure. At a high level, we're taking what the network already knows and turning it into clear, intuitive guidance. Here's what happens under the hood. We pull the floor layout from Cisco Spaces and bring it into our application. We overlay a coordinate grid on top of the map image. From Spaces, we get live telemetry that tells us the coordinates of 1, person who needs help, and 2, the first responder. Our app maps the coordinates into pixels on the image so we can plot both points on the map in real time. We constantly calculate the distance between those points using basic geometry. That distance is what drives the sonar effect. There's a meter above the map that pulses brighter and faster and plays a ping sound as the responder gets closer, and calms down as they move away. So instead of just saying they're somewhere on this floor, we give responders something that feels more like a digital homing beacon they can follow under stress.
And if we're big on anything here at Ironbow, it's definitely partnerships. So how did the partnership with Cisco make this all possible?
Well, honestly, this only works because we're standing on the top of a really strong Cisco ecosystem. We have Cisco Catalyst Center that gives us our reliable source of truth for sites, floors, and network devices. We have Cisco Unified Communications Manager, Emergency Responder, and Red Sky handling the call routing and the 911 behavior. Cisco Spaces is giving us the real-time location telemetry in the floor maps. And we have Splunk, which is letting us detect the 911 events and trigger our application automatically. So Cisco provides the platforms, APIs, and local intelligence. Our role was to stitch them together into one cohesive workflow. The partnership means we're not inventing everything from scratch. We're orchestrating proven Cisco capabilities in a new way. So customers get more value out of the investments they've already made and ultimately deliver safer outcomes on the ground.
And we only had 4 months to build this, so we had to use what was available.
Oh my goodness, I can't even imagine. 4 months, it's just mind-blowing. All right, gentlemen, so we've come to this part of the episode where it's time to nerd out. For the tech-minded listeners, what were some of the biggest technical hurdles in connecting so many different systems? Probably the time constraint sounds like one, but would love to hear about the others.
One of the biggest challenges we had with all these platforms is they all think about location and identity differently. Each have their own data models, their own APIs, their own idea of what the important fields are. So we had to solve a few hard problems. Data model alignment. The hierarchy in Catalyst Center doesn't look exactly the same as the location data in Emergency Responder or Red Sky. So we had to design a common model and then build translation layers so that updating Catalyst Center once reliably turns into the right configuration downstream. Identity stitching. In one system, you're dealing with MAC addresses and IP addresses. In another, you're dealing with extensions, users, and calling numbers. We had to reliably tie those together so an event, like a 911 call, can be traced from the phone number to the device to the network device to a physical place. Real-time but resilient workflows was another one. When a 911 event hits, you don't get to say, sorry, the API rate limited me. We had to build something that feels real-time but also idempotent, retriable, and observable. That meant carefully handling of queues, backoff, and error conditions across multiple APIs that were never originally designed to be in one pipeline. In short, the hardest part wasn't any single API, it was getting all of them to behave like one coherent system.
That key integration component again. So it sounds like you had to reverse engineer certain elements, and of course you mentioned work around limited APIs. What did that process teach you about creativity and engineering?
You know, it really did reinforce that a lot of the interesting ideas come up when you're having a constraint or you're hitting a speed bump or something like that. There were definitely moments where the platform did not expose exactly what we wanted it to do. In some cases, we had to infer behavior from logs and events, or just work with what the API would give us instead of what we ideally wanted. And each time that forced us to step back and ask a different question. Instead of, why doesn't this API give me X or Y? We started asking, given what it does give me, how can I still deliver the outcome that we want? A great example of this is the mapping and guidance piece of our solution. The solution supports using Cisco Space's built-in Wayfinder capabilities, but for our demo, we couldn't use that because we didn't have a CAD file for our environment. So we built our own. We brought in the floor layouts, added our own grid, mapped the telemetry to the image, and layered a sonar guidance on top. And that workaround ended up becoming one of the most unique parts of the solution. So the big lesson was, creativity in engineering isn't about having unlimited options. It's about being stubborn about the outcome and flexible about the path. Frankly, the constraints from these systems pushed us to design something more original than we probably would have if everything had been easy.
I'm kind of obsessed with stubborn about the outcome, flexible about the path. Now that is a motto right there. And I think what makes this even more exciting too is there is an AI layer to this. So I'd love to touch on that. Looking ahead, how could AI make this even smarter? Like predictive alerts, maybe anomaly detection, maybe even location forecasting?
AI naturally fits into this space because we're sitting on a lot of rich, time series spatial data once everything is integrated. A few directions I'm excited about: anomaly detection and drift. AI could watch patterns over time and say, this access point's behavior doesn't match its configured location. Or, these 911 calls always seem to come from an area where your data is incomplete. That's a way to catch problems before an emergence exposes them. Predictive safety signals. Over time, you could learn patterns around incident types, locations, and times of day. Here are hotspots where configuration, staffing, or signage might need attention. Smarter guidance on scene. Once you've already plotting first responders and callers, AI can help with path suggestions inside the building. Use this corridor instead of the one based on historical movement or current conditions, or automatically adapt the interface depending on what type of incident it appears to be. Or proactive testing with speech to text. Use AI to automatically place scheduled 933 test calls, transcribe the audio responses, and compare the address, caller ID, callback number, and the response of what the source of truth thinks it should be. If anything is off, wrong building, old floor, missing callback information, the system can flag it, open a ticket, or alert an engineer before a real 911 call ever happens. Over time, you get a continuous health check on your emergency calling environment instead of relying on the occasional manual tests. AI is really the next layer that can sit on top of this foundation and help organizations move from reactive response to something much closer to a proactive and predictive while keeping humans in control.
And just so exciting. I mean, just more lives saved, big things in the future and ahead. So speaking of kind of what comes next, how does this innovation fit into the bigger picture of Cisco and Ironbow's partnership?
I see this as a really clear expression of what the Cisco-Ironbow partnership is supposed to be about. Cisco provides incredibly powerful platforms like Catalyst Center, their collaboration stack, emergency calling, locations, and analytics. And Ironbow's role is to orchestrate those pieces into outcomes that meet our customers' needs and matter in the real world. In this case, the outcome isn't just a well-configured network, it's faster and more accurate responses to emergencies. We're taking the Cisco investments our customers have already made and layering Ironbow's automation, integration, and workflow design on top so that everything behaves like a single coherent safety system instead of a collection of silos. So this innovation fits into the bigger picture as a proof point. When Cisco's platforms and Ironbow's automation expertise come together, we're not just configuring products, we're configuring an integrated solution to bring about desired results.
Amazing. And looking into our crystal ball here, predicting the future, what do you think's next? Where do you see the solution heading in the new year and beyond?
Well, the first phase was about proving we could automate the plumbing, keeping data in sync, react to a 911 event, and guide responders with clear visual cues. So looking ahead, there are a few directions I'm excited about. First is basically scale and coverage. Can we make it easier to roll this out across more sites, more campuses, more customer types, without a huge amount of bespoke engineering each time? I'm thinking this as can we take a successful project and turn it into a repeatable platform? Okay? The second is we'd like to see some deeper integrations, tightening the loop between the network, infrastructure, voice, operation tools, so that changes anywhere in the environment automatically flow through this new safety workflow. The goal is that engineers declare intent once, somewhere in their system, and the system quietly keeps everything aligned. Okay? And then there's the intelligence level. As we collect more operational data, there's a lot of potential for smarter alerting, drift detection, and guidance that helps organizations be proactive instead of purely reactive. So by 2026 and beyond, I see this less as a one-off solution and more as part of a broader safety and automation fabric that Cisco and Ironbow can bring to any complex environment where someone truly needs to know who needs help and exactly where they are, and that's mission critical for them.
Many, many exciting things ahead, it sounds like. So, Jim and Jeff, if you had to sum it up, what's the big message behind this project? I know one big great takeaway from today is stubborn about the outcome, flexible about the path. What else does it say about innovation in public safety today?
When someone dials 911, there's chaos, stress, and incomplete information. Our job as engineers is to make sure the technology reduces that chaos, not adds to it. That's why we focus so heavily on automation and the data sync, taking all the systems organizations already rely on and making them behave like one coherent safety engine instead of a bunch of disconnected islands.
Yeah, to us, that's what modern innovation in public safety really looks like. It's not flashy dashboards for their own sake, but quiet, dependable workflows that keep data aligned, guide responders to the right place, and give people in crisis a better chance. It's about turning the network and the collaboration stack into something that just doesn't move packets and calls, but actually helps to save lives.
Well, that's the key thing here, right? The saving lives. And lastly, what advice would you give to other technologists or partners who want to build solutions that make a real world impact like this one? It's just wonderful to see you both applying your technical expertise and talents and doing this for such an important cause, such an important mission and outcome.
Get ideas from lots of different perspectives and keep your mind open to the unexpected solutions.
That's true. It definitely takes a team. And I'd also add in, you don't need to be a programmer on the team. We need expertise from all different technologies.
Amazing. Thank you so much, Jim and Jeff, for sharing the story behind this incredible innovation and for reminding us how powerful technology can be when it's built with purpose. If you enjoyed this episode, be sure to subscribe to Tech in Translation on your favorite listening platform. To learn more about how Ironbow's partnering with partners to transform everyday tech challenges into amazing outcomes, visit ironbow.com. Thanks for listening, and we'll see you next time.